So this is just a quick review of sketching polynomials, but really what we need to do is we need to factor first. So let's practice factoring, and then we'll do one question where we go and sketch a problem. So the problem is, so when we do polynomials, if it's not factored, we have to factor them first. So let's review a lot of the factoring methods. This one, for the first one, this is common factoring. So here, that is the first thing we must do. We always must do that. Always do that first. So I look for the common factor of x cubed minus 4x squared. So that value is going to be, well, the highest power is x squared that we can pull out. So in the bracket, you have to think about it like this. X cubed divided by x squared gives us just x minus 4. And there is our answer. Now for the next one that we have here, we have 4x squared plus 8x. So now this time we have a coefficient that's common. And we also have x's that are common. So we're going to pull that out and we're going to end up with 4x is the highest number we can pull out, and then we're left with x plus 2. The next problem we have here is we have negative 6x cubed, and we have a common factor that we can pull for 4 and 6. So I'm actually going to pull out negative 2 because I want to always have no negatives sitting on my highest power in the bracket. So we're going to have, well, negative 2 pulled out. Then our highest power of x, our lowest power of x that we can pull out is 1. So we're just going to pull out an x. Now what we're left with is, well, negative 6 divided by 2 gives us negative 3. No, positive 3. X squared minus 2. Now, if we go a little bit farther, we can get negative 2x, and if we take the square root of the first part, we're going to get, this is a difference of squares. We learned about that last year, and we'll talk about that a little later. So we look at this, and we can take the square root of this, and we get the square root of 3, x, and we go minus the root of 2, because the square root of 2 is just the square root of 2, and then we get the root of 3x plus 2. Now remember, this whole part here is called a difference of squares. This allows us to find the roots of things. So notice, we look for something that's squared minus a number to the side, and then we can pull it out. Now, let's go and take a look at simple trinomials. Well, what we're looking for here. You notice that the coefficient that's in front of this is 1. And because it's 1, all we're looking for is numbers that add to negative 7 and times multiply to 12. So two numbers that multiply to 12 and add to negative 7. So those two numbers are going to be this. Well, it's going to look something like this, but we don't know what goes in here. So because the middle number is overall negative and the last number is positive, I know immediately that both numbers have to be negative, because two negative numbers multiplied together give us a positive. Now we just got to figure out what those two numbers are. If we try 2 and 6, that doesn't work. 2 and 6 doesn't add up to negative 2 and negative 6 doesn't add up to positive 7. negative 7. So let's try negative 3 and 4. And we end in the end, negative 3 plus negative 4 does add to negative 7, which is what we want. We're going to do the same for the rest of these. So we look for the next one, we have x squared plus 4x minus 12. Now, because this is plus 4x in the middle, because we have a positive 4x and a negative 12, we're trying to find a number that multiplies to negative 12 and adds to positive 4. Now, what this immediately tells me is that I have two numbers that multiply together. So those two numbers could be 3 and 4, 2 and 6, 12 or 1. Now, because the middle number is positive, I automatically know that the bigger number has to be positive, because the bigger number plus the negative number that we identified as the multiplier, because a plus and a minus gives us a negative here, is going to be bigger because the middle number is positive. So I'm going to try 4 and 3. 4 and 3 is 12, right? Now if I take negative 4 plus 3 is 1, negative 1, so that doesn't work. How about 12 and 1? 12 and 1. Okay, so if I take 12 and 1, I've got negative 12 and 1. That doesn't work. That gives us negative 11. So let's try positive 6 and negative 2. So actually that works. So we have positive 6 and x minus 2. For the next one, we do the same process again. And we end up with x plus 6 and x plus 1. Now, the only reason I know this is because the last number is positive and the middle number is also positive. That means both numbers have to be positive for the final answer. That's why we end up with 7x. Now, for the last one here. Like before, in order to make your life easy, we have to find the first. We always start for common factoring. So we're going to pull out a negative x. So what we're left with in the bracket is x squared minus 5x plus 24. Nope, that doesn't work. Let's fix that. Which is, well, x squared and then negative 5x minus 24. So, because we know our last number must multiply to negative 24 and our middle number is adding to negative 5, we know that the bigger number is going to have to be negative. So, let's go and do this. Negative x, well, 8 and 3 multiplies to 24, so I'm going to take negative 8 and multiply by positive 3 to get negative 24, and then negative 8 plus 3 gives us what we want in the middle. Next, let's go take a look at difficult polynomials. For difficult polynomials, one of the ways we can do this is we can use guess and check. So the key idea is to look for basic multiples of the first part and the last part. Because these two numbers are prime, I know that I have 2 and 1 and 5 and 1. And the key idea is we try to find some form of multiplication. So I know that 2 times 1 gives 2, which is what we want for the 2x squared. But then we also have 5 times 1, which gives us that. So that works for the end. So now what we have to do is we have to figure out which one's going to be negative and which one's going to be positive. Because we have a minus 3 here, I think what we're going to have to do is we're going to test out a negative 5. Negative 5 times 1 gives us 5. Plus 2 times 1, which gives us, oh wow, that works. That actually worked. So we're going to end up with something like this. Bracket 2x minus 5 and one x plus 1. So the top half of this represents the first bracket and the bottom half represents the second bracket. So let's do the same again for these other ones that we have. And just the last thing, we'll take a look. We know that this and this gives us plus 2x. And this gives us minus 5x. When we add those two together, we end up with minus 3x, which is what we want. Now our next problem is 3x squared and 3x squared minus 13x minus 10. So in this case, I'm going to try, I've got 3 and 1 again. 3 and 1, but then I also have 10. 10 could be broken into, well, I could make it 10 and 1. Let's try that. 3 times 3 times 1 gives 3. Perfect. 10 times 1 gives 10. Yeah, that works for the last part. But now let's see if we can get the middle part. So I actually want to have a total of negative 13. So I got to make a negative 10. So I think I'm going to try negative 10 here. That doesn't work because 10 plus 3, 10 plus, oh boy, negative 10 plus 3 gives us negative 7, which is not what we want. So let's try that again. So let's try 5 and 2. But this case, I think what we'll do is we'll try negative 5 and 2. So 3 times 2 is 6. And no, that doesn't work. So maybe what we have to do is we have to rearrange the 5 and the negative 2. So let's say I have 2 here. 2 and negative 5. All right, 3 times negative 5 gives us negative 15. Plus 2 gives us negative 13, which is what we want. So our first bracket is going to be 3x plus 2. And our second bracket is 1x minus 5, which is what we wanted. We'll do the same for this next one. Let's try. So this next problem is 4 and 3. So 4 can be written as 2 and 2, and 3 can be written as 3 and 1. So let's try that. So we need to get the middle number to total up to 14. To do that, we do our cross multiplication and add. Yowza, it doesn't work. So we end up with 6 plus 2, which is 8, which doesn't work. So we're going to have to try this again. Let's try 4 and 1 and 3 and 1. 4 and 1 and 3 and 1. So 4 times 1 is 4. Plus 3 to... Nope, that doesn't work either. So we can't do that. So let's try 1 and 3. So let's rearrange it. I see something that looks good. So 4 times 3 is 12. Plus 1 times 1 is 13, which gives us our middle number, which is what we want. So our brackets are going to be these things. Our first bracket is going to be 4x plus 1. And our last bracket is going to be x plus 3. So now for this last one, we're always going to have to look for some sort of common factor to make our life easy. So I'm going to pull out a 2. So we get x squared plus 6x minus 16. I already know my answer for this. So I'm going to go and use 2 and 1. Nope, That doesn't work either. That doesn't work either. So I need, this problem here makes my life easy because I know I need two numbers that multiply to -16 but add to +6. Those two numbers are going to involve 8 and 2. So I'm going to have x, and because my middle number is positive, I know that my overall biggest number must be positive. So I got +8 and x minus 2. There's our factor form. The last of these are called the difference of squares. So let's see if you can get the pattern. Notice I have a perfect square here, x squared, and I also have another perfect square, 9. Square root of 3, square root of 9 is -3, is 3. So we end up writing x plus 3, x minus 3, or x minus 3 plus 3. And the same can be done for the rest of these. Square root of 4x squared is 2x. And we'll go plus 1. And we get 2x minus 1 for this next one. So the two perfect squares are the square root of 4x squared is 2x. Plus, what's the square root of 100? 10. We get 2x minus 10. And for the next one, always start by factoring out something common. So I'm going to factor out a 3x. What we're left with in the bracket is x squared minus 16, which means that we have 3x and we have a perfect square in here. So we have x plus 4 and x minus 4 as my final factoring. Now, because I have x to the 4 and x to the 2 for this, we can break these two into two parts. I need two numbers that multiply to 13 and add to 36. -13 and add to -36. So we're going to get, well, the square root of x squared is just going to be x squared minus 9. Because we're going to split that up and we're going to get x squared minus 4. So these both break into x minus 3, x plus 3, x minus 2, x plus 2. Now for the solutions on these next problems. Here we go. So I'm just going to motor through them. Try each of them and then take a look. We have to graph these after we're done. So